Am I, can you see my screen, friends? Hello?
Yes, sir.
Yeah, thank you. Just I'll put a message in the group. So today we will discuss about hash tables and hash techniques and what is hashing and is there any problem with that and how does that will help us? What is the need of knowing about hash? It is important topic, hashing. Wait for 2 minutes for others to join. Okay, friends. Hello, friends. Hashing. So hashing is, it is a data structure. It is used to store the elements and retrieve the elements in an efficient way and also in faster way. And you can give various definitions. We can define hashing in various ways. One is hashing is a technique in which elements can be stored and retrieved from the memory very faster. Or hashing is an algorithm, or hashing is a data structure used to maintain the elements in an efficient way through the memory. So we have various ways to store the elements into the memory. If whatever the data we have, we can store into the computer memory and we can retrieve whenever it is necessary. So for that, we have various options, and hashing is also one of the excellent technique for storing and retrieving data into the memory from the memory. And how this can be done? The hashing technique We will use a data structure called hash table. We'll use hash table. This hash table can be defined based on the number of elements to be stored. If you want to store 10 elements into the memory and your hash size should be 10 or more, then only you can store the 10 elements into the memory. And if the hash size is 100, sorry, if you want to store the 100 elements and the size should be greater than or equals to 100. How many locations are there here? Here it is. That index, this hash table index starts from 0, 1, 2, 3, 4, and 5. So how many elements can we store here? Speak out, no?
5.
No, 6. Index is starting from 0, no, ma'am. 0 to 5. That means 6 elements you can store.
Yes.
So how this storing or inserting elements can be done into the hash table? There are various methods. So hashing is the technique to maintain the memory efficiently for storing and retrieval of elements. So using hash technique or hash data structure, we can use the memory efficiently and we can reduce the time for storing and retrieving. And you can save the memory also. The advantage of hashing technique is time saving and memory saving. So ultimately that will leads to cost also. It reduces the cost. So example, if you want to store some elements, how can you store into the hash table? For that, we have various methods. To store the elements into the hash table, we have various techniques. One techniques or methods. One is division method. And the other is mid-square method. And the third one is digit folding method. These are the 3 available methods to store the elements into the hash table. Hash table is nothing but a memory. So this can be done using these three methods, and we will see one by one how this division method will be implemented to store the elements into the hash table, and how this mid-square method will work, and what about the digit folding method to store the elements into the hash table. We will see one by one. Digit folding method we will see. Kalyan, why are you annotating? Digit, digit folding method. Sorry, division method. Kalyan, are you mad? So how this digit folding method will be implemented? So for the digit folding, sorry, division method, we will use a hash function. how that hash function can be defined and how that will work. Example, if you want to store uh, the elements like 6, 7, 8, 9, 10. We just consider them. In this division method, we will use a hash function, a special function called hash function. That function is like h indicates a hash of key is equals to key modulo size. This is hash function. What do you mean by key here? Key is nothing but the element what you want, which you want to store in the hash table. Here the keys are 6, 7, 8, 9, 10. And the size is nothing but the size of the hash table. Here, how much is the size?
5.
Sorry?
5, 6, 7, 8, 9.
6.
5 or 6?
0, 5, sir.
How?
6, 7, 8, 9, 10.
Those are the keys I am asking. The size is nothing but the size of
Size.
the hash table.
Size is 6, sir. 6. Hash table size is 6.
Yes, that's what. Hash table size means 0 to 5 are there, no? The size of the hash table
Yes.
is.
5 plus 1.
Yeah. We will see how this function will be implemented. First, we should take the h of key. What is the first key?
6.
6. You can take any key, no issue. And 6 modulo size is 6. Here, this is size. Is equal to 6 here. So 6 modulo 6. If you divide 6 with 6, what is the remainder?
0.
0 only. The hash function will result the integer. The hash function is used to get an integer. That integer will indicates the index number of the hash table. We have 6, 7, 8, 9, 10 elements. These elements should be stored in the hash table. Where should we store? At which location we need to store a particular element? For that, in this division method, we will use a hash function. This hash function formula is as you seen on the screen. The result of hash function should be an integer. That integer indicates the location, index location. This is index number of hash table. So where should we store the 6 now? What is the
0.
index now?
0.
Yes. 6 we have to store at 0. Now we have to take again the next number.
Take as carry.
Yeah. 7 modulo 6. If you divide 7 with 6, what will be the remainder?
1.
1. So this is index 1. So where that 7 should be stored?
Index 1.
Yes, it will be stored at index 1. And now again we will see h of 8. If you divide 8 with 6, what will be the remainder? It is 2.
2.
So 7 must be stored, 8 must be stored at. No, here it is 7 now, friends.
6, 3, 7, 2.
Now you can take, what is the next key? H
9.
of 9 modulo 6 is 3. If you divide 9 with 3, sorry, 9 with 6, 6 ones are 6, the remainder will be 3. This
3.
is what this is. So now you need to store the 9 at,
Index 3.
yeah, index number 3. And the next element of
10.
this is of 10. That means 10 modulo 6 is equals to 4. So now we have to store 4 at, sorry, 10 at,
Number.
look,
Index 4.
this is what? Understood or not?
Yes, sir.
Others?
Yes.
Is it visible to you?
Yes, sir.
Yeah. I have decreased the size of the table.
Just zoom a little.
Sorry.
Just zoom little bit.
Okay. Is it okay for you?
Okay, sir.
Yeah, fine. Now, this is what the division method to store the elements into the memory. Now you can, we will see about mid-square method. We'll see division method, sorry, digit folding, mid-square method now. That is method 2. Can I erase it?
Sure.
Mid-square method. This is also a method to store the elements into the hash table. So how this can be done? For the same thing, we will take some, we'll define a hash table. For indices from 0, 1, 2, 3, 5. So here also the size is 6. And consider some elements like it is like 15 and 20, 25, 31, and 9. And we'll take some 18. Let's consider this. So how this mid-square method will work? So first, there is no function to implement this one like division method. In only division method, we will use that hash function. This mid-square method, we have to square the digit. Whatever the element we need to store, we have to square it. First, 15 square. How much it is?
225.
225. What is the mid value?
2.
Yes. This is our index number. So this here we have to store 15. Next, this is 20.
20. 400. 0.
This is 400. It is 0. So the mid value is 0. So that value, that number will be stored at 0th location. Sorry, not this one. It is 20. Now again 25. It is 625. Its index is 2. So here is some problem. See, if you store this 25 again in this location,
Submit this.
that 15 will be overwritten and 25 will occupy the place. This is having some problem. Same location as 15. We will discuss about this one. In this case, what we should do. Now again it is 31. It is 31 square is
12, 3, 3, 9, 941.
941.
Just a minute. 3,
What here?
3, 3, 3, 3, 9.
It's 961, no?
Yeah, yes, sir. 961.
No. 961. If it is 961, what is the mid digit here?
6.
6. But we don't have the location 6, right?
Yes.
What should we do in this case? If it is not having that index number, you take the next one. Either this or that.
1.
Yes. This will be stored at 1. This is 31.
What if index number 1 exists already?
That I'll tell later, no? See, if already 15 is there at index 2 and 25 is also has to be placed at index number 2. So
Yes,
that's
sir.
why I have put it in the box, because there is some problem with that, because already some number is existing in that location. Again, we
Okay.
that mid square method has suggested as some other number. If the index number is not there, not available, mid square number, you can go with. If it is the same, then we will see. 18 square, how much it is?
18.
It is, I think, 324. It is 2. Again, it is 2.
Same location.
Yeah, same location as 15. So there is some problem with this. Same location as 15 and 25. This problem is called collision. Whenever 2 or more elements
Indicate the same index.
are, 2 or more elements are indicated or needs to be placed at the same location, then that problem is called collision. We can't store the same 2 numbers or 2 elements at the same location, because if you store the first one, again, if you store the second element in the same location, that second element will occupy the space of the first one. That first will be automatically overwritten. So that will be totally disappeared. Whatever you store latest, that will be the element. If you take 15 as the first, then again this mid square method suggests 2, index 2 means 25 is also suggest the same location. If you store the 25 at 2, 15 will be gone. Then again 18 square, it is also suggesting index number 2. If you store this 18 at index number 2, that 25 will go and 18 will be there. So what should we do? In this case, in this situation, here, in this problem, we are about to lose the elements 15 and 25 due to 18. Due to the same index number of 15, 25 and 18 is the last one. So this 25 and 15 will be totally disappeared and we will lost that information. We don't know where is 15, we don't know where is 25. Totally that will be disappeared. So out of 5, we are going to lose only, we are going to lose 2 elements. So that is not the accurate thing. This is called collision. A collision is the situation in hashing technique in which 2 or more elements or more than 1 elements wish to occupy the same location. So for this problem, there is some solution. So as of now, you just only think about how this mid-square method will work. In this mid-square method, you need to square the digit or element, whatever you want to store. You square that number and you take the middle number as the index number. Whatever is the middle number, you check whether that number is available as index number in the hash table. If it is available, you can store it. If it is not the same, the size is not like that, then you can take then any other choices of the digits. You can take any other digit and you can store. And if there is a problem of collision and there is some solution for that. So mid square method lo em chestamu number తీసుకోవాలి square చేయాలి mid digit తీసుకొని middle number తీసుకొని అక్కడ store చేయాలి. Is it clear, friends? We will think about this collision problem later in few minutes. As of now, you should know about how this mid square method will work.
Yes, sir.
Yeah, this collision problem will also occur in the division method also. We will see it later.
Okay.
Can I move
Yes, sir.
for the next one?
Yes, sir.
Next one is digit folding. Please mute yourself, friends, please. Digit folding method. So how this digit folding method will work? Same, you need to define the same some hash table. Like I'll take only with the lesser size. The index number is 0, 1, 2, 3. You consider some elements to store like 1, 2, 3, 1, 0, 1, and 10. And it is, okay, let it be, take this 3. And what should we do? The digit folding method will work based on the folding of the digits. How can you fold the digits? You can fold the digits in the number by using any of arithmetic operations. Example, the first number is 1, 2, 3. Does it have digits? Yes, it is having digits. You can implement anything. Like I want to do some addition of first 2 and -1, or simply you can go with addition of all the digits or subtraction. Take the 6. You can go with addition of the numbers like 1 plus 2 plus 3. What is the total? 6.
Six.
You can store this element 1, 2, 3 at index number 6. 1, 2. Again, now you take the next element 1, 0, 1. This is 1 plus 0 plus 1, it is 3. You can store that at 3. This is 1, 0, 1. Next, you can take the next element. This is 1, 0. 1 plus 0, it is 1. So you can store 10 at here. This is what digit folding method. Not only addition, you can implement anything. You can do like addition. You can do addition of first two and subtract from the last three. Or you can subtract all the digits. 3 minus 2 minus 1. Or you can multiply all the digits. You can get it. Digit folding method. So I'll take one more number here. Like you see, I'll take 30. Here 3 plus 0. It is 3. So you can see these two indices. Here 101 and 30 should be placed at or indicating this location. So here also the problem of collision is occurring. So this method as suggested for 101 and 30 is the same index number is 3. So what should we do? This is called collision. This collision problem will occur while inserting using any method. Maybe division method, maybe digit folding, maybe mid-square method. There are some chances to raise the problem of collision while inserting the elements into the hash table. Then how this collision problem will be resolved? Eventually collision వస్తే elements అనేవి loss అవుతున్నాయి. Data loss అవుతుంది. Elements will be overwritten by one by another. So to overcome this problem, there are some techniques to overcome the collision problem and not to having the loss of any elements. ఏ ఎలిమెంట్ లాస్ అవ్వకుండా ఎగ్జాక్ట్ గా అన్ని ఎలిమెంట్స్ ఉండేలాగా మనము ఎఫిషియెంట్ గా స్టోర్ చేయాలి హ్యాష్ టేబుల్లో. ఫర్ దట్ వీ హ్యావ్ సమ్ టెక్నిక్స్. దోస్ టెక్నిక్స్ విల్ బి కాల్డ్ యాజ్ collision resolution techniques. Sorry, collision resolving techniques. One minute. Right, man. Fine, right. Right. So there are two techniques for collision resolution. So you should know about what is collision. The question may come in the exam like what is hashing, explain various types of hashing, and what are the various collision resolution techniques. Collision resolution technique. First, we should know about collision. Collision is the situation in which more than one elements or keys are mapped with same location. Or you can write it in informal way. Collision is the situation in hashing in which the more than one element is wish to place in the same index number. So this collision resolution techniques we will see. Collision resolution technique or resolving technique. Collision resolving techniques. What are they? There are two techniques for collision resolution. One is sequence chaining or chaining, and other is open addressing. Sequence chaining and open addressing. These two techniques will help us to avoid or overcome the collision problem while inserting the elements into the hash table. What do you mean by sequence chaining and how that can be implemented? So sequence chaining uses this linked list. Like this is index number 0, 1, 2, 3, 4, 5. In the sequence chaining, we will call these elements, this indices of the hash table will be called as a bucket. We will not insert the elements here. We won't use this location to insert the elements in the sequence chaining. Rather than, we will use a linked list for the index number, and we will store the elements in the these linked lists. I'll show you sequence chaining. How this will work? Consider a hash table with the index numbers 0, 1, 2, 3, 4. So sequence chaining is example, take some elements like 5, 4, 9, 13, and like 10 and 14. Just consider these elements. We need to how to store this up. Sequence chaining uses division method to insert, like h of 5 is equals to 5 modulo 4. How much it is? If you divide 5 with 4, what will be your remainder?
1.
1. So you have to store that element 5 at index number 1. So here, unlike this division method or mid square method or linear probing, sorry, this digit folding, we will use a linked list here. What is the data here? 5 we should store here. Next, what is the next element?
Excuse me,
4.
sir.
Yeah, please.
Sir, hashing table size 5, sir.
Hashing table size is? Yeah, sorry.
5.
Yeah, thank you so much. Hash table size is 5. Thank you, madam. Yeah, we should use 5. It is 0. Thank you. So in this case, it should go here. This is 5. Now the next element is 4. 4 modulo 5. How much it is?
4.
4, exactly. Is it 4? Or 0? It's 4 only because the dividend is lesser than the divisor. In this case, the remainder will be the dividend only. So here we have to store 4 here. Next, again, the next element 9. 9 modulo 5. How much it is?
4.
4. So 9 is also suggesting index number 4. So you can store this one here. The next element should be 13. So 13 modulo 5, it is 3, no? 3, 3. You divide 13 with 5, your remainder will be 3. So in this case, you can go with index number 3. Next number is h of 10. You divide 10 with 5, the remainder will be 0. So 0 means again we have to store it here. This is 10. Next number is 14. How much it is? If you divide 14 with 5, the remainder will be 4. So now you can store the element here. This is what. Is there any problem here to lose the elements? What do you mean by me is there any chance to overcome the element? You can store the numbers in separate nodes. In linked list, we will call them as a nodes. So there is no chance to overcome the elements. This will have some memory, this will have some memory, this will have some memory. This will be called as a node, and a node. Every same index number will be stored in a separate node. So there is no problem of collision here. Understood or not? Please, if you have any doubt, let me know, or else I'll move forward. I need your response, guys.
Yes, sir.
Shall I move forward?
హలో సార్,
Yes, please.
పక్కన గ్రీన్ కలర్ లో రాసింది ఒకసారి ఎక్స్ప్లెయిన్ చేయండి.
Okay. That is called linked list. I think we have not discussed linked list now. Linked list is the data structure that is used to store the elements by linking one with other. So if you divide this 5 with 5, you'll get the index number 0, right? Those who asked the question. Oppo K10.
ఎస్ సార్.
Yes, this is index number is 0. So in this sequence chaining method, we will not able to store this element in the bucket. This is called bucket, this red color, this one. Rather than in the sequence method, we will take a linked list. This is called a node. Means this will store the element and this will store the address of next element. This is a node, this is a node. Numbers or keys will be connected one with another. So what are the elements have been stored at index number 0? Index number 0 లో ఏ నెంబర్స్ స్టోర్ చేసాము? 5 is
5,
there,
10.
10 is there. So you can identify easily. ఇంతకుముందు ఎలా ఉండే, ఇఫ్ యూ టేక్ ఏ హ్యాష్ టేబుల్ 5 ఇక్కడే స్టోర్ చేసేయాలి, మళ్ళీ 10 కూడా ఇక్కడే స్టోర్ చేయాలి. అప్పుడు 10 స్టోర్ చేసినప్పుడు 5 అనేది ఓవర్ రైడ్ అయిపోతుంది. అప్పుడు అలా లాస్ అవ్వకుండా ఈ హ్యాష్ టేబుల్ తీసుకున్నాం. దీంట్లో సీక్వెన్స్ చైనింగ్ మెథడ్ లో ఏ ఇండెక్స్ లో ఎలిమెంట్ వస్తుందో అక్కడ ఒక లింక్ లిస్ట్ క్రియేట్ చేసి ఎలిమెంట్ ఇలా స్టోర్ చేస్తాం. దిస్ ఇస్ కాల్డ్ ఏ లింక్ లిస్ట్. నెక్స్ట్ వన్, దిస్ ఇస్ 4. దిస్ ఇండెక్స్ నెంబర్ ఇస్ 4. సో యూ కెన్ టేక్ ఏ నోడ్ హియర్ ఇన్ లింక్ లిస్ట్, స్టోర్ 4. And next is also 4. Already ఒక నెంబర్ ఉంది కాబట్టి you can create one more node and you can store the 9 here. Next number is 3. So its index number is free. You can create a node. This is linked list and you can store it. And next number is 0, but already some node is there. You can take one more node. You can store 10 here. And next is 14. Index number is 4. So you can create next node. You can store. It will go like this. So what are the elements have been stored at index number 4? 4, sorry, this is 4 or 14? Yeah, 4 only. 4, 9 and 14 have been stored at index number 4. So there is
Okay,
no
sir.
loss. Sorry?
థ్యాంక్ యూ సార్. ఓకే.
Yeah, there is no loss of data here. ఈ లింక్ లిస్ట్ లేకపోతే ఎలిమెంట్స్ అన్ని దీంట్లోనే స్టోర్ చేయాలి. దీంట్లోనే స్టోర్ చేస్తే ఏమవుతుంది, లేటెస్ట్ ఏది స్టోర్ చేస్తే అదే ఆక్యుపై చేస్తుంది మెమరీ. రిమైనింగ్ ఎలిమెంట్స్ విల్ బి లాస్ట్. సో దిస్ ఇస్ ద టెక్నిక్ ఫర్ రిజాల్వింగ్ ద collision. So using this sequence chaining method, there is no problem of collision. All the elements will be identified. All will be given the importance, equal importance. The next one is open addressing. Open addressing. In open addressing, again, we have some methods. One is linear probing and other is quadratic probing and some other technique is also there, double hashing. So we have this linear probing and quadratic probing as per our syllabus. We will discuss these two. If time permits, we will discuss this double hashing also. And this question, you need to write about the methods, types of hashing, means how can you insert division method, mid-square method, digit folding method, and collision resolution techniques, sequence chaining method, and open addressing. In open addressing, you can explain about two. That's enough. We'll see linear probing method. Linear probing is a part of open addressing method. Just a minute. Sorry, I had a call. Okay. Linear probing method. This also we will use division method, but in using different formula. You take one example. Oh. This is the hash table. Zero, 1, 2, 3, 4, 5. So there are the size of the table is 6. Hash table size 6. So the elements are like, you can take any random elements. 10, 5, 12, 13, 15. Let's second. H of key is equals to key plus I modulo size. So what is extra here when you compare with division method formula?
Plus I.
I.
Sorry, I.
Plus I.
I is only the extra added for when you compare with the division method. So what is this I? I is an integer, a natural number starts from 1. Natural numbers are starting from 1. So you can take numbers from 1 and you can implement if you get the collision. You can take I value as 1. If you find the index number free, you can store it. If you take the index number I value as 1, Although if you are getting the collision, you can increase the I value to the next number. I'll explain you. So first, h of 10 is equals to 10 plus 1 modulo 6 here. How much it is, friends? 11 modulo 6. It is 5. If you divide 11 with 6, the remainder is 5, no? So we need to store 10 here. It is free. Index number is free. We can store it. The next element, h of 5 is equals to 5 plus 1 modulo 6 is equals to 6 modulo 6 is equals to 0. So you can store in element 5 at index number 0. Next, h of 12 is equals to 12 plus 1 modulo 6. It is 13 modulo 6. How much it is? 1. If you divide 13 with 6, your remainder will be 1. So you can store 12 here. Next, h of 13. 13 plus 1 modulo 6 is equals to 14 modulo 6 is equals to 2. So we can store here. Next one is h of 15. 15 plus 1 modulo 6 is equals to 16 modulo 6 is equals to how much it is? 4. So index number 15 you can store. I'll take one more element. Can I erase it?
Sir,
Yeah, I'll take one more element like 12 I'll take. 12 already came, no? 11 I'll take. If you take 11, so h of 11 is equals to 11 plus 1 modulo 6 is equals to 12 modulo 6. How much it is? 0. But already some element is there at 0, no? Till
Yes, sir.
15, we don't have any problem. We have identified non-allocated index number. Simply we have allocated. Now there is a problem. There is a collision. So in this case, what should we do? In this case, you have to increase the I value. Like you take h of 11 is equals to 11 plus 2. With one collision occurring. 6 you take. How much it is? 13 modulo 6. Again, you are getting collision. 1 is there, no? Index number 1 is also there. Something is existing. Are you getting my point, friends?
yes, sir.
Yeah. Next, we have to take the next one. You can take I value as increase. 11 plus 3. Modulo 6. How much it is? 14.
14%.
14 modulo 6. 2. But index number 2 also some element is there.
Yes, sir.
Next, you increase the I value. Like that, you need to increase the I value. 11 plus 4. How much it is?
10 by
15. 15 modulo 6.
3.
You'll get the index number 3. But, right? 15 plus 3. 15 modulo 6. Index number 3, no? If you divide 15 with 6, you will get index number 3. So 11 has to store here. So this is called linear probing. You have to increase the I value once you get the problem of collision. If the collision occurs with the linear probing problem, you have to increase the I value and you have to do the division until you get the free index number. Got my point?
Yes, sir.
Others?
Yes, sir.
Yeah. Next method is quadratic probing. This is other technique of open addressing. Quadratic probing. How this quadratic probing? It's same like linear probing only, but instead of I, we will take I square. I'll explain with small example. Hey, bravo. This is 0, 1, 2, 3. Index size, hash table size is 4. Four, 5, 8. Let's consider these elements to be inserted. So this formula is h of key is equals to key plus I square modulo size. So now you take 4. చెప్పండి. 4 is equals to 4 plus 1 square modulo size is 4. So how much you get it? 5 plus, sorry, 4 plus 1 modulo 4. That means 5 modulo 4 is 1. So you need to store this. Next, h of 5. So 5 plus 1 square. This is 5 plus 1. This is 6 modulo 4. You'll get index number 2. here we need to store the 5. H of 8. 8 plus 1 square. This is equals to 8 plus 1 is equals to 9 modulo 4. 9 modulo 4 means you'll get the index number 1. So there is a problem with this. Already, but some element is existing in 1. So you need to go with other. H of 8 is equals to 8 plus 2 square is equals to 8 plus 4. That means 12. 12 modulo 4. Index number is 0. So you need to store 8 here. You got it, friends? It's same like linear probing only, but instead of I value as 1, you need to take its square. Instead of I, we need to take I square. I value will start from 1, 2, 3, 4 like. Is it clear or you want me to explain again?
Okay, yes, sir.
Is it okay?
Yes, sir.
Fine. Yeah. Okay. This is what hashing. So we have discussed about what is hashing and what are the various methods of hashing and what is the problem in hashing and how the hashing problem will be resolved. We're using various techniques. Now you give me an option. We have 2 topics to discuss, 3 topics. One is queues and other is linked lists and the third one is AVL trees. I think in the last class we have discussed AVL trees. Friends, you let me know which topic you want me to discuss.
Sir, double circular linked list.
These queues and linked lists are important for 10 marks and this AVL tree is important for 20 marks, I feel. I'll go with majority. Please response. Give your response faster so that I
Yes,
can.
Sir, sorry, double circular linked list.
Double circle linked list. We need to discuss about entire thing. What is the linked list? Single linked list, double linked list, circular linked list, and double circular linked list.
Okay, sir.
I need others' opinion. You want AVL trees or linked list or queues? This class is not only for a single person, Komal. This is for you all.
లింక్ లిస్ట్ కావాలి సార్.
Linked list. We have discussed ABL tree in the previous class, right? I think.
Yes, sir. చెప్పారు sir.
But did you get that solution to that problem? I have given one problem, one question. Some Hij, some elements are there with the letters. So that is very, very important, I told. And
అది
I have
హాఫ్ చెప్పగానే క్లాస్
discussed
తీసుకోవడం మానేశారు సార్.
కరెక్ట్. నో దానికంటే ముందు నేను ఏబిఎల్ ట్రీ అంటే ఏంది, దాని యొక్క అసలు ఆ ప్రాబ్లం బ్యాలెన్సింగ్ ఫ్యాక్టర్ ప్రాబ్లం వచ్చినప్పుడు ఎలా రొటేట్ చేయాలని చెప్పాను. దేర్ ఆర్ 4 types of rotations.
Left, right, right.
Yeah, if the node is unbalanced, then we have to do various 4 rotations. 4 possible rotations are there based on the situation, based on the problem, based on the insertion. You can go with the right choice of rotation. Left rotation is there, right rotation is there, left right rotation is there, right left rotation is there. So using those 4 rotations, you can, I have given the problem, you can try to rotate the elements of that node, the tree, and you make it balanced. That is very, very, very important, I told. Okay. I have discussed mostly all the topics of this ABL tree except the problem. So I'll go with linked list now. Linked list. A linked list is a linear data structure in which the elements are stored in sequential manner. A linked list is a linear data structure used to store the elements in a sequence manner. In the linked list, nodes elements are connected in sequence manner. Or you can define in other way, a linked list is a data structure with connected nodes. I'll write it here. With connected nodes. Nodes will be connected. We have seen that linked list in the hash table sequence chaining, no? How that is happening, we will see. Linked lists are 3 types. Single linked lists, double linked lists, and circular linked lists. Single linked list, double linked list, and circular linked lists. So we will see one by one. What do you mean by single linked list? What are the various operations can be performed on linked lists? The operations will be same for all these 3 types of linked lists. Whatever you perform on single linked list, double will be same as for double linked list and circular linked list also. So I'll see single linked list. A single linked list is a data structure. It's a type of data structure in which elements are stored in the nodes and nodes are connected one with another. Every node will have 2 parts. Every node will have 2 parts. One is data part and other is address part. First is data part and other is address part. And there will be 2 pointers. The first pointer is head pointer. And last point is null pointer. Indicates starting node. This indicates last node. First node and last node. Head indicates the first node in the list and null indicates last node in the list. We'll see how this list can be. Example will be like this. Head. You take some number here. Every node will have its own address here actually. Example, its address is 100, its address is 205, its address is 604. So here you can write 205, 604. So we have discussed that every node will have two parts. This is data part, indicates the element, actual element. This other parts indicates the address of the next node. Why? Because to which node it has been linked. ఈ node ఏ node కి లింక్ అయిందో తెలుసుకోవడం కోసం every node will maintain two parts. One is data part. Data part means the actual element what you want to store in the memory. And the address part is the address of the next node. This is what. You understood this? This is called linked list. This is single linked list. If you have any doubt, please ask friends. If you understood this single linked list well, then double linked list and circular linked lists are nothing. It's easy. Sorry? Yeah, please.
Sir, address of first element మరి అది ఎక్కడ ఉంటుంది సార్?
Address of first element.
H6 ఇది.
No, that there is no element in front, no.
Yes,
Before
sir.
that, there are no elements, no. That address
Okay.
only. So you can come to know there are two addresses, no. 100 is there. That is the address of first element. So you
Okay.
can come to know at which address element 6 is stored.
Okay.
At address 100. And what is the next element? Next element is stored at, you can see beside 6205 is there, no?
Yes,
The
sir.
next element is stored at address 205. Got it?
Yes, sir.
6 is stored at address 100. And what is the next element of 6? Next element
Yes.
of 6 is at address 205. You can type 205. You can get the element whatever is there stored at address 205.
Okay, sir.
So what we have discussed about single linked list. A single linked list is a type of linked list. It is a data structure. It will have nodes which are connected, and every node will have two parts. One is data part and other is address part. Data part contains the actual element to be stored in the memory. Address parts contain the address of the next node. And also there will be two pointers in single linked list. One is header pointer and other is null pointer. Header pointer indicates the first element or first node in the list. Wherever you see the head, that will be the first node. Wherever you see the null, that node will be the last node in the list. Is it clear, friends?
Yes, sir.
Others?
Yes, sir.
Next, we can see, we'll see now what are the various operations can be performed on single linked list. Operations on single linked list. So there are mainly the following operations are there in single linked list to be performed. One is insertion, and other is deletion, and the third is search, and fourth is visiting or traversal. These are the main operations on single linked list. These are the same operations will also be performed on double linked list and circular linked list. Insertion. Insertion can be done in three ways. Deletion can also be done in three ways. Means there are three possible ways for insertion and three possible ways for deletion. And searching is used to search the elements in the linked list. List lo ఏ ఎలిమెంట్ ఎక్కడ ఉందో ఐడెంటిఫై చేయడం కోసం we'll use the search. And visiting, we can visit all the nodes, all the elements in the nodes in the list using the visiting operation. And what do you mean by insertion? You know it well. Insertion is nothing but storing elements into the memory, and deletion is nothing but removing the elements from the memory. So if you know these operations well, if you understood these four operations well, and the same operations will be performed on double and circular linked list. We can discuss about, we'll discuss now insertion operation on single linked list. Insertion operation on single linked list. Insertion can be done at three locations, three ways. These are the three ways: insertion at the first, insertion at the last, insertion at the middle. So we can see now. We have the list. Consider we have the list. This is a head. This is 6. This is 10. This is 8. This is null. You take the address randomly. This is 9004 8060 3240. So this is 8060 will come here. 3240 will come here. So this is the existing single linked list. Suppose you want to insert an element called 4 as first. You have the element. You have to insert the 4 as the first element in the list. What should we do to make an element as the first node? First, you need to define a node. You take a node as the first, and you store that 4 here, and you take this head pointer and you put to this. Head ఎక్కడ ఉంటే అదే స్టార్టింగ్ పాయింట్ అవుతుంది. And you give some pointer to the this 6. It is 8060. This is 9004. And this is 8 3240 8060. So this is 10, I think. This is 8. This is null. This is 3240. And once you define a node, address automatically will be generated. Like consider this is as 1008. And this address will come here. 9004. So what we are doing here, we are simply creating a node before the first node. And we are pointing this header pointer to the new node. కొత్తగా ఒక నోడ్ డిఫైన్ చేసాము, ఆ నోడ్కి హెడ్ పాయింటర్ తగిలిస్తున్నాము. ఈ ఆల్రెడీ ఉన్న ఎగ్జిస్టింగ్ లిస్ట్ లో ఫస్ట్ నోడ్ యొక్క అడ్రస్ వచ్చేసి ఈ న్యూ నోడ్ లో అడ్రస్ పార్ట్ లో ఉంటుంది. అండ్ దిస్ న్యూ నోడ్ విల్ బి లింక్డ్ టు ద ఆల్రెడీ ఎగ్జిస్టింగ్ లిస్ట్. ఎనీ డౌట్ ఇన్ దిస్? Please let me know.
No, sir.
Okay, fine. We will see insertion of node at the end. At the end, how can you insert? 4 only there. 4 as at last. So ikkada head will be there. What is the first element? 6. And it is 8060. This is head. And next element is 10. 3240. This is 8060. And next element is 8. This is 3240. And at the end, you need to create a node. If you want to insert node and place this one here and change this null pointer to here. This will be null and its address will be like something. And this address will be placed here. 08. You create one new node at the end and you put null pointer to the newly created node, and the address of newly created node will be placed at the address part of the last node of the previous list. ఇంతకుముందు లిస్ట్ లో లాస్ట్ ఏముందో దాని యొక్క అడ్రస్ పార్ట్ లో కొత్త క్రియేట్ చేసిన నోడ్ యొక్క అడ్రస్ అనేది ప్లేస్ చేస్తాము. ఇంతకుముందు ఉన్న నోడ్ లో లాస్ట్ లో ఉన్న నల్ తీసుకొచ్చి ఇప్పుడు కొత్త క్రియేట్ చేసిన నోడ్ లో నల్ పాయింట్ చేస్తాము. That's it. This is what insertion node at the last. You need some clarification or any ambiguity, any confusion? Please let me know.
Okay, sir.
Sorry?
Okay, sir.
Okay, fine. We'll see the node next. Insertion of the node in the middle. Sorry, insertion of the node in the middle. This is what we are discussing. So head will be there as it is. 68060. Some address will be there like. And if you want to insert the node between here, 4 రావాలి అనుకోండి. You put as it is 10, 3240, 8060. And you can insert node here, new node. It is 4. Its next node is null, the last node. Anyway, null. Its address will be 3240. You put its address here, and its address will be like 2005 3240, and you change the address of this node to this one 2005. That's it. ఏం లేదు, మధ్యలో ఒక నోడ్ ఇన్సర్ట్ చేస్తాము. ఇక్కడ 4 వస్తుంది. ఈ లింక్ వచ్చేసి దీనికి ఉంటుంది, ఇది వచ్చేసి దీనికి ఉంటుంది. ఈ అడ్రస్ ఇక్కడికి వస్తుంది. దీని యొక్క అడ్రస్ ఏదైతే ఉందో అది వచ్చేసి ఇక్కడికి వస్తుంది, అంతే. దట్ ఈస్ ఇన్సర్షన్ ఇన్ ద మిడిల్. Can I go for deletion?
Yes, sir.
Yeah. Deletion can also be done in the 3 ways. Deletion of a node in list. Head 6 is there, 1005. 10 is there. 2006. And 12 is there. 9040. This is null. If you want to insert, sorry, if you want to delete 2006 here, 9040. If you want to delete the first node, what should we do? Just cut this node, break this link, and move this pointer to here. Point the head pointer to the next node. Automatically, wherever head is there, that will be the first node. ఇక్కడ ఉన్న పాయింటర్ తీసుకొచ్చేసి ఇక్కడ ప్లేస్ చేస్తాం, అంతే. సెకండ్ నోడ్ కి అపాయింట్ చేస్తాం. దెన్ దిస్ నోడ్ విల్ బి ఇగ్నోర్డ్ automatically. So this will be the first node. The list will continue. And for deletion of last node, what should we do? ఫస్ట్ నోడ్ డిలీట్ చేయాలంటే హెడ్ పాయింటర్ తీసుకొచ్చి నెక్స్ట్ నోడ్కి పెట్టాము. లాస్ట్ నోడ్ డిలీట్ చేయాలంటే ఏం చేయాలి?
9040 తీసేసి నల్ అక్కడ పెట్టాలి.
ఎగ్జాక్ట్లీ. యూ జస్ట్ పాయింట్ దిస్ నల్ టు హియర్. ఇక్కడికి నల్ వచ్చేస్తుంది అంటే ఆటోమేటిక్ ఈ అడ్రస్ పోతుంది. ఇక్కడికి నల్ వచ్చేసింది అంటే ఇది ఇగ్నోర్ అయిపోతుంది అనమాట. అప్పుడు దిస్ విల్ బి ద లాస్ట్ నోడ్. ఈ అడ్రస్ ఓవర్ రైట్ అయిపోయి దానిలో నల్ వస్తుంది. జస్ట్ టు డిలీట్ ద లాస్ట్ నోడ్ ఇన్ ద లిస్ట్, యూ జస్ట్ పాయింట్ null pointer at the address of the previous node of the last node. Second last node లో null pointer పెట్టాలి, అంతే. That is deletion of the last node. And now deletion of the middle node. ఏం చేయాలి? 10 తీసేయాలి నేను. How to delete?
2006 లో ఈ
Hmm.
9040 వస్తుంది.
Break these links. How to break? ఈ నోడ్ తీసేసాం అనుకోండి, అప్పుడు ఏమవుతుంది? ఈ నోడ్ తీసేస్తే ఈ రెండే ఉంటాయి కదా, ఈ అడ్రస్ ఇక్కడికి వస్తుంది అంతే. థ్యాంక్ యూ, నైస్. 9040, దాట్స్ ఇట్. అప్పుడు ఇది దీనికి లింక్ అవుతుంది, ఈ అడ్రస్ బేస్ చేసుకుని. దిస్ ఇస్ డిలీషన్ ఆఫ్ ద మిడిల్ నోడ్. నెక్స్ట్, search. So search is also used at 6, 10. This is 8. So search will help us to identify a particular element in the list. ఒక నెంబర్ కావాలి నాకు, 10 కావాలి. Whether 10 is available in the list, it will search the entire list and it will give you the result. Search is only to identify the elements in the list. And visit, traversal is to visit all the elements. List లో ఉన్న అన్ని ఎలిమెంట్స్ విజిట్ చేయడానికి traversal యూజ్ అవుతుంది. That's it. Now we will see the double link list. Operations అన్ని సేమ్. Double linked list. What is a double linked list? It is also a types of a linked list. It's a data structure in which each node will have 3 parts. Each node will have 3 parts. Data part. This is, data part will be in the middle. This is address of next node. This is address of previous node. Data part అనేది middle లో ఉంటుంది. Previous node, address of the previous node is the left side of data part, and the right side of the data part will be address of next node. You see example. And there will be 2 pointers for the first node and 1 pointer for the last node. Total 3 points will be there. I'll show you. This is 4, 6. This is 10, this is 8. This is head pointer. Null pointer. Its address is like 008, 1004, 1009. ఇప్పుడు previous address ఇక్కడ ఏం లేదు దీంట్లో, null. What is the next address of this node? 1004. What is the previous address of this 10? 1008. What is the previous address of 8? 1004. It is null. See this one? This header point indicates that this is the first node, and this indicates that previous node. Is there any previous node to this node?
No, sir.
No, that's why we are pointing it as null. Previous node లేదు కాబట్టి null గా పాయింట్ చేస్తున్నాము. Does it have any next node? Yes, it is. Its address is the 1004. next node pointer. Coming to this node, its previous node address is 1008. Its element is this one, and its next node address is 1009. Coming to this node, its previous address is 1004. Its next address is no elements, no node. So we are pointing it as null. These points will be there, these pointers. Every node in the double linked list will have 3 parts. In the 3 parts, first part is address of previous node, and second part will be the data part. And the third part will be address of the next node. And the pointers, there are 2 pointers will be there for the first node. One is head and other is null. Head is to indicate that this is the first node, and null is to indicate that there are no previous nodes in the list. And then the last, we have only one null pointer, that is to indicate there are no next nodes. That is the last node. And the operations will be same. Insertion, how to insert the first node? If you want to insert a node at the first, you remove these 2 pointers for the first node and place it to the next node. ఈ పాయింటర్స్ రెండు తీసేసి ఈ 2 పాయింటర్స్ తీసుకొచ్చి దీనికి పెట్టేస్తే దిస్ విల్ బి ద ఫస్ట్ నోడ్. సారీ, దీనికి ఇక్కడ కొత్త నోడ్ క్రియేట్ చేసినప్పుడు ఈ పాయింటర్స్ తీసేసి ఆ నోడ్కి పెట్టాలి అంతే. అండ్ హౌ టు ఇన్సర్ట్ దట్ ఎట్ ద లాస్ట్? యు ఇన్సర్ట్ నోడ్ in the last and change the pointer of null of the last node to the newly inserted node. మిడిల్ లో ఇన్సర్ట్ చేయాలంటే ఆ 2 పాయింటర్స్ మధ్యలో ఉన్న 2 పాయింటర్స్ చేంజ్ చేస్తాం. సేమ్ లైక్ సింగిల్ లింక్ లిస్ట్. And this is what double linked list. Operations will be same. And coming to circular linked list, I think they may close the session. Only 2 hour session. Circular linked list. In the circular linked list, no null pointer. Circular linked list is 2 types: single circular linked list and double circular linked list. 6. Oh. We'll see the addresses. 1004, 1005, 1008. Class loan. Hello, class loan, class loan. 1005. This one, the next node address is 1005. This is 1008. And what is the next node? Next node of the last node.
1004.
Yes, this is circular linked list. No, this is what. So there is no null point. It will not end. There is no end actually. So it will rotate. This is called circular single linked list. If it is circular double linked list, we have to indicate 2 pointers, previous and next. Understood? Understood or not? Operations will be same. Insertion in the middle, insertion in the starting, insertion in the last. Let me know if you have any doubts.
No, sir.
Okay, friends. That's all for the day. All the best for your